All right, so 7.6 homework here, we're looking at number 65. So this is through 1970 to 1995. The percent, which is what we're calling P here, of doctors and medicine degrees earned by women each year is modeled by this function. So this thing being raised to the 1/2 makes it a square root function. So when I'm looking at this thing, it's going to have a domain. We haven't done a lot with this whole having a x squared value inside of it, but basically it means it can kind of open up in two directions. So we're just going to concern ourselves with what the possible ones are, and that's going to be all of our positive values of t. So when we're doing time, basically we're going to call 1970, 1970, year 0. And so when we go out to 1995, we've only gone 25 years. So that's going to be our time scale here. Let's see. In what year were about 36% of the degrees earned by women? So here we're going to look at 36 as a percentage. So when we're doing this problem here, we're basically just saying, okay, well, when is this P number going to equal 36? So let's write this out as 36 equals, and here we have our, and I'm going to write it with a root like this just to show you can represent the same information two different ways. So here's 0.867 t squared, and I'm going to write this with x as well, again, just so my t's don't get confused with addition signs. So t is x here. Let's see, plus 39.2x plus 57.1. So in order to solve this thing, what I want to be doing is squaring both sides. So I'll take this whole right side and I'll square it, and that means I'm going to square this side as well. So when I'm doing this, I'm saying, okay, well, let's get whatever 36 squared is. 1296. So 1296 is going to equal now all this stuff on the inside. So now I get my 0.867x squared plus 39.2x plus 57.1. So when I'm solving this problem, I'm just going to solve it like a quadratic from here. So I'm going to get this thing set equal to 0. Clearly messy numbers, so I'm going to use my quadratic formula rather than try and factor this thing. So in order to get it set equal to 0, I'm going to subtract over my 1296. And so I get 0.867x squared plus 39.2x. And now here we got subtract, let's see, 1238.9. And that's going to be equal to 0. So now I want to find my A, B, and C values. So I'm going to scroll down a little bit here. Oops, too much. So when I'm looking for A, B, and C values here, my A value equals 0.867. My B value equals 39.2. And my C value equals negative 38.9. So I'm going to set this up. So I'm going to do negative B, which is negative 39.2, plus or minus. Now I've got my B squared value, so 39.2 squared. And we're definitely just going to round to the hundredths place on these things. So 1536.64 minus 4 times A times C. So here I've got my A value of 0.867 times, again now, so I'll write the whole thing out. I'll just do 2 separate steps. Keep in mind that I'm multiplying a negative with a negative, so this is going to end up being plus whatever. So now when I do this, all divided by 2 times my 0.867. Let's simplify this thing. So we get negative 39.2 plus or minus the square root of. So this stuff right here turns into, let's see, 4296 point, call it 51. So here I'm doing that plus my 1536.64. So this inside ends up becoming 5833.16. And this is all being divided by 2 times 867 gives us 1.734. Cool. I'm only looking for positive times. I'm looking for 1970 and beyond. So I'm going to pretty much just ignore this value right here, the negative one. So I'm just going to focus on the plus. So here I've got my 39.2, and I'm going to say plus my square root of 5833.16. And I'm going to take that whole thing, which gives me approximately 115.58. Roughly. And I'm going to divide that by 1.734. And we get approximately 66.65 years, which seems a little bit off. I think it probably would have been between the 0 and 25. So let's see what maybe I screwed up here. The only thing I can think of is that it's using 0.36 here instead of 36 as the actual percentage.
Mr. G?
Yeah.
If we get a really long number, do you want us just to round it?
For ones like this, if I gave you a problem like this on an exam, I would tell you round to 2 decimal places. Yeah. But for
Okay.
other ones, you can just leave it as exact numbers. But again, they'll be like, it should seem obvious which are which. So like questions like this are going to be round to 2 decimal places. Other ones, I'm just going to have you guys keep everything exact. So like on the exam, I don't even think there are any rounding ones off the top of my head. The quiz gives you a pretty good idea of what the exam will look like too, so you can check that out.
Awesome.
All right, so doctors earn degrees. Saying 36% equals this. What year? Square both sides, subtract this thing over. ABC values, squared.
I have a question.
Yeah.
To get to 115.58 over 1.734, did you add negative 39.2 or did you like subtract it?
Oh, that's what it is, Molly. You got it. I missed my negative sign there. Thank you. That's not right, and therefore this won't be right. Kudos to Molly. Cool. So let's go back and let's do the actual number, which would have been negative 39.2 plus that square root, which would have given us 37.18. And then we divide that thing by 1.734, and that's where we get our 21. Much better. Bonus points to Molly. Perfect. So here we're getting 21.44. Say it again.
So you do subtract the negative 39.2?
Well, this is negative, so it's like a negative number and then plus whatever this thing is. I wouldn't want to do the negative this and then minus, because then I'm talking about years in the past.
Oh, okay.
Yeah, good question. So does this part make sense, the 21.44, now that we fixed that one thing?
Yeah.
Perfect. So if I were to show you guys just, again, a modeling version of this. So this is Desmos. You can graph stuff in Desmos. Here's what our kind of curve looks like here. Our root function like this opens up pretty quickly, but if I zoomed out, you can see that the thing eventually will kind of trail off. The scale is super large, so we don't see it happening as quickly as we'd like. It's very hard to show. But basically, because I end up squaring this thing, it ends up being, I don't know, it kind of cancels it off. So this isn't really like a legitimate root function, but that's okay. So looking at this, we have our intersection point here at, approximately 21.44, which is what we got. Sweet. Any questions on this one? Perfect. Saved by Molly.